In this lesson, we're going to take what we have learned in preceding lessons about sine, cosine, and tangent and apply them to the concept of a unit circle. We're specifically going to look at what a unit circle even is, then we're going to talk about how the sine, cosine, and tangent trig functions apply to unit circles. So let's start off by reviewing what in the heck a unit circle even is in the first place. This circle you see here is an example of a unit circle. How do we know it's a unit circle? Notice it has several key characteristics. First of all, it is centered on 0, 0, right in the middle of the coordinate plane. And also notice that it has a radius right here of 1. Now, because this unit circle has a radius of 1, it means any other point on this circle is exactly 1 from the center. So if we had a point, say, right here, it's going to be 1 away from the center. If we had a point right here, it's going to be 1 away from the center. Doesn't matter where you go in the circle, the radius is 1. And because the circle has a radius of 1, it means it intersects the x-axis right here at positive 1 and also over here at negative 1. This is where y equals 0. And it also intersects the y-axis at 1 and at negative 1. This is where x equals 0. So within the circle, we can draw angles. Now, the vertex of the angle will always be right here in the center of the circle at 0, 0, right in the middle of the coordinate plane. Now, the first side of the angle we draw, this one right here, is called the initial side. The second side we draw here is called the terminal side. Initial, terminal. By drawing the initial and terminal sides, we have created an angle right here. We'll just call it theta, whatever theta happens to be. This one, just guessing from the way the line is angled, we're probably looking at 45 degrees. We're not going to worry about the exact measure of the angle right now. Just understand that these two lines create angle theta. One key point here that you need to keep in mind is the fact that because we rotated counterclockwise as we drew our angle, the initial side was here, the terminal side was here, counterclockwise. Because of this, this is actually considered a positive angle. I know it's counterintuitive, but it's true. If we had went in the other direction, we started with our initial line here and drew our terminal line, say down here, going clockwise, then it would have been considered a negative angle. So at this point, we need to consider where these lines that we drew that form our angle intersect the circle itself. Now, the coordinates for the intersection of the initial line, we already know. It's right here, What is the value of x at this point of intersection right here? It's 1. What's the value of y at this point of intersection? It's 0, isn't it? We're right on the x-axis. So this is 1, 0. Now notice up here that the terminal line also intersects the line of the circle, but the point where the terminal line intersects up here is not known. So we're just going to call it a, b. And obviously you can see that both a is going to be less than 1, x is less than 1, and b, our y value, is also less than 1. We don't know what those values are yet, but we do know they're less than 1. So you might be asking at this point, why do I care about this unit circle thing? It's because it can be used to solve a variety of trig problems. Now we do this by turning this angle right here into a right triangle. To make this into a right triangle, we draw a line from the intersection point of the terminal side down to where it meets the x-axis, which is the initial side right here. This forms a right angle, a 90-degree angle right here, and as such, we've just created a triangle. This is our opposite side over here, side B. This is our adjacent side down here, A. Remember, the adjacent side is right next to angle theta. The opposite side is opposite angle theta. And guess what we have up here? Our hypotenuse. Now, because this is a right triangle, we can use our standard trig functions to learn more about the length of its sides, A and B.